Okay, so first we're going to talk about the transition metal naming, then we're going to talk about types of bonds, how to identify the type of bonds, then we're going to talk about the separ, the shapes, then polyatomic ions, how to name those, then polarity, van der Waals, and then hydrogen bonding the last. That's the last piece we'll do. Alright, so the first part, naming transition metals. And feel free to stop me whenever you guys have a question. Naming transition metals. So whenever you have a transition metal, you just don't know how many it's going to give off. So iron, in this case, this is the formula right here. If you're ever given the formula, and you need to go to the, I don't know, going to the name, you're going to need to put parentheses. So here's a transition metal, and let's say that it's bonded with, I don't know, oxygen. Okay, so we've got iron, and we've got oxygen. Normally, you just, like, the first reaction would be to say, oh, well, that's iron oxide, right? But since this is a transition metal now, we need to know how many of these electrons it's giving away. You knew that right away. 2. Well, how did you know that, though?
Because oxygen needs 2.
Because oxygen needs 2. That's right. So oxygen does need 2. Okay. This one needs 2.
So this is transition plus non-metal?
This is just transition and then a non-metal. Yes, that's a ionic bond. This whole thing is an ionic bond.
So iron gives 2.
So this, since this is, it needs to, you know that. How do you know that? You look at the periodic table. Of course, you're laughing at it, but believe me, people will get stuck with this. It needs 2 electrons because it's in the 6th group of the periodic table. It needs 2 more electrons to have a full valence shell. So it needs 2, so big deal. We've got one of these atoms right here. So that must mean that since we have just one of these iron atoms right there, this must give 2.
Because it can give how many it needs, however it wants, right?
Yeah, it can give up as many, for our sake right here, it gives up as much as this one needs. So this one's going to give 2. And the way we write that is not like this. It's not like that. Okay, people get confused with that too. It's not like that. It's like a Roman numeral. Alright, that's iron 2 oxide. Now, let's now complicate the situation more. So let's say instead of it just being FeO, let's say now it's FeO2.
You're going to need 4.
So the total amount of electrons that these oxygens need are 4. It needs 4 now, a total of 4. So that means that this iron right here is going to need to give how many?
4.
4. It's going to need to give 4. So whenever you're stuck with this, just take a step back and say, okay, so how many does that one need and how many is that one giving?
But if the second atom is a transition metal too,
Oh, that's not going to happen. That'll be a metallic and a metallic bond. We're just doing ionic bonds and covalent bonds for naming. Okay, so that one will be a give 4, so that, of course, would be like that. Now, the tricky part comes in when you have stuff like this, where you have, I don't know, like when this has Fe3. I'm going to erase these right now.
Fe3?
Fe2, let's do this, Fe2O3. Okay? Now, what's the name of this? Well, you have to think about how many total this oxygen is needing. Total amount. 6. So it needs 6. But now, check this out, we've got 2 of those irons right there. So how many is each of these irons going to give? So each gives, how about this? We have to say this a little bit differently now. Each gives 3. So now this is going to be iron 3 oxide.
And you don't put any number after iron to show how many iron there are, right?
That's right. Okay? So because this needs a total of 6, and you've got 2 of these right here, it would be iron 3 oxide. Okay? But let's even make this, let's make it a little bit simpler though, because that's the hardest kind of question I can ask. Let's say it's just Fe. What would the amount of electrons be that each of these iron atoms is giving right here? Each gives 6. Well, there's only one. each gives 6. So that would be iron 6 oxide. Okay? So that one example covers a lot of different situations there. All right? Now that's going from formula to, this is the name right here. Formula to name. Let's do the reverse. Let's go from the name to the formula. All right? Let's say that I'll just use a different metal here. It doesn't matter. I could have stayed with iron. I'm just going to say, what's your favorite one? Let's use tungsten as a W. I like that one.
That's my favorite
Tungsten. Tungsten, and then let's use, just for trickiness, let's use nitride. Tungsten nitride.
This is named formula.
This is now named to formula. Okay? So before it was formula to name, now it's named to formula. And let's say that its name is tungsten, yeah, let's stick with 6. Tungsten 6 nitride. All right. So the first step you do right now is you just say, okay, well, what are the symbols here? Well, for tungsten, it's a W. W. It's weird.
W and N.
And the nitride is N. W-N.
Wait, what?
Right? But now you got to see how many of each of these you really got here. So since nitride, that is taking, how many is that
You
taking?
have 2 nitrogen.
Takes, how many does it take?
3.
It takes 3. And tungsten, how many is that giving here?
6.
Gives 6. Okay.
So it's quasi.
Ah, you can! Well, let's just move these up over here. I'm just going to put these up over here on this side. Gives 6, and this one takes 3.
So it's W 3 and 6.
Yeah, that works. You can also simplify it too. This one goes over there to be 6. This one goes over here to be 3.
So W and 3.
You could do that, yeah.
And
So
would be
this
mine.
would simplify, this simplifies.
If you don't simplify it for
No, it's not
W
wrong.
and 2.
It's fine. Simplify it to this. You can simplify it to W, and then N. So half of 6 is, oh wait, 6 divided by 3 is what? 2.
Oh, so, oh,
WN2.
Oh, close.
that's too late for me.
There it is.
Okay, want a cookie?
Yeah, actually, go big.
Simplify to that. All right.
That's pretty good.
Questions about that?
I'm just a little confused when you do like that come up with formula to, especially with the transition metals, because it's just kind of confusing inside of each atom that's
Yes. So you just have, that's just something you just, I don't know if there's any other way for me to kind of like help you out with that. It's just,
So you have to like look at what element it is and know how many electrons it needs to have a full balance shell, and then you see how many, and that would be the number that the transition metal gives to each one.
that's how many that the transition metal gives to total.
Totally.
So like we said, like we had before, if you, let's say, like, let's just use this example right here. And let's pretend that we don't know this. Okay? Let's say it's W, let's just do this. It'll be the same answer. W and 2. Okay? Now, you have to go from here to there. Okay? So, nitrogen, how many does each nitrogen need? Each nitrogen needs 3, so a total, so each needs 3,
In total 6.
so a total needs 6. Right?
Oh, why do you want right total there when you do it on the other side of right each?
Yeah. Yeah.
So each gives
A total things.
So
when
each,
you write it out, you wouldn't put 6, you'd put 3, right? That's the number that each specific. Right?
say that again, I'm sorry.
When you write it down, you write 3 because each nitrogen needs 3.
In this case?
when you write it out.
Oh yeah. Well, you could say each. You could say that either one works. I'll put that on top.
Would you put 6 or would you put 3 in the parentheses?
Well, you could say each needs 3, but the total is 6.
Right.
So we need to fulfill its total need. That's what we're looking for.
But when
Right?
you write it out, would you write out the 6 or would you write out the 3?
You'd write out the 3. Oh, I'm sorry. You'd write out the 6. Okay?
So
Because.
you always do the total when you write it out in the parentheses.
So in the wait, you said that you always get the total when you write it out in the parentheses. So when what you mean by that is, what I want to say is that for here, look at how many each of these gives
Right.
to make the total happy. Does that make sense? To satisfy the total, you got to see how many each gives. So for this, each here is going to give a total of 6.
But in the example before with the iron, you said that for Fe2O3,
Yeah.
you said it was iron 3 oxide. And then the iron 6 oxide.
You have to think about it. Each of those iron atoms is giving how many? 3. So it'll give a total of 6 altogether.
Right, but in parentheses you said write 3, not 6.
Right. Right. So you're talking, in the parentheses, you talk about what each of these atoms are giving, so that the total amount of electron needs over here is fulfilled. Okay?
Yeah.
Watch the tape again, rewind it, okay?
Rewind and rewind.
All right. Next, I think it's still recording.
Lol.
I hope so. Oh, totally. Yeah, we just got that. Okay. So that took a while. That's okay. That was a nice, thorough discussion of that. I think that really it was clear for me when I was saying it. Yeah.
Just really quick question.
Yeah.
Having to do with naming.
Yeah.
When we go from name to formula, when is it, or like formula to name, when is it one of those polyatomic ions?
Yeah.
And I'm not, like, I forgot, is it gold and metal, not metal?
Polyatomic ions?
I'm really confused right now.
Let's just go through polyatomic ions when we get there.
Okay.
Let's talk about types of bonds right now.
When you have the really long ones in parentheses, and then you
Yeah.
have enough, like,
So little subscript.
yeah, like I get confused with this.
Okay.
Polyatomic?
Yes.
Okay. That's such really dumb.
All right.
I failed that part of the quest.
Well, we can make this bigger. I'll make this bigger. Formula and name. All right. Next, let's talk about types of bonds. So there are 3 types of bonds. One of them is metallic, one of them is ionic, and the last is covalent. So we're only going to be naming 2 types of those bonds, ionic and covalent, right? So this one is just really a definition. I don't know if you want me to go into any more detail than this, but if you have a covalent bond, it's going to be 2 nonmetals put together.
Share.
Right, they're sharing electrons. If you've got an ionic bond, it's going to be a 1 metal and 1 nonmetal. Yes, that's right. And the metal can be a transition metal, which is why it makes it kind of confusing to name. But it's still, it obeys the same rules as ionic bonding. So right now Nino is pointing to all of the metals. Yes.
Okay, I'm sorry.
It's okay. So yeah, there all the metals. You can, and then you have the